Okay, today's goal. Solve systems of equations. Now we have two methods under our belt already. We have substitution and we also have graphing. Both systems, solving systems methods work nicely. Today we're going to talk about a new method. And that method is the elimination method. The elimination method is nice because it's going to remove one variable pretty easily. First, let's talk about our goals for today. We want to answer this question with a resounding yes. Can we solve systems of equation using an elimination method? Hopefully, and I think that we will. That'll be one big old yes, no problem. So let's review quickly. A system of equations. It's simply two or more equations that have the same variable or that have the same variables. X, Y, A, B. It doesn't matter what the variables are. As long as they share them, they both have them. And a solution to a system is all the points or a point that satisfy both equations. Oftentimes with linear equations, we're going to have three different types of solutions. No solutions, which is called inconsistent. One solution, which is consistent and independent. Or infinitely many, when the lines lie on top of each other, and that would be consistent and dependent. We're looking for that point that makes both equations true. So we're going to use an elimination method today. Elimination simply means to get rid of. In this case, we want to get rid of one variable, either the x or the y most often. And we want to do that because solving for one variable allows us to find the solution pretty easily. We know how to solve in one variable. We're going to use those skills today to help us. We're going to use the theory of, or the idea of opposites. Now, opposites in math often refer to a positive to a negative or a negative to a positive. And so when we take the numbers 4 and negative 4, we know that 4 minus 4 is going to give me 0. We like that idea. They get rid of each other. We're going to use it, though, in order to add and or subtract equations to eliminate a variable with common coefficients. Look at this. We've got 3 and we've got negative 3. We look at those and we know that 3x plus negative 3x, the coefficients are opposites of each other, give me 0. We want to look for coefficients that are common. We're going to add or subtract the equation to eliminate those common variables with coefficients or common coefficients. Okay? So let's look at an example. I've got negative 4x minus 2y equals negative 12. I've got 4x plus 8y equals negative 24. When we look at this, we see pretty quickly, hopefully, negative 4x and positive 4x. And we know that they're opposites. When we add those together, we're going to get 0. Now, we can add two equations together because, as I've said multiple times, in math you can do anything you want as long as it's fair. Because this is equal to negative 24, I can add it to the top because I'm really, in theory, adding the exact same thing. And so, let's add them together. And the reason why we want to add them together is this right here. Negative 4x plus 4x cancels out. My x values are now gone. My variable is completely gone. Negative 2y and positive 8y leaves me with 6y equals negative 12 plus negative 24 is negative 36. Now we're just going to solve for y. And we get that y is equal to negative 6. I've got a value for y. I can simply solve for x by plugging in. I'll take this first equation. Negative 4x minus 2y equals negative 12. I've got a y value. Let me plug in. Negative 4x minus 2 times negative 6 equals negative 12. Negative 4x minus plus 12 equals negative 12. Okay? I'm going to add 12 to both sides. Subtract 12 from both sides. And now we've got negative 4x equals negative 24. Simply solve by dividing by negative 4. X equals 6. The solution to this system would be 6 comma negative 6. Be careful, as I just showed you, hey, the algebra and working with those negatives is really where we're going to have our most amount of silly mistakes. Be careful of those silly mistakes. Try to avoid them. Another example. 3x plus 2y equals 5, and x plus 2y equals negative 1. Right away, we should notice 2y and 2y and think to ourselves, hey, you know what? Those are the same. What can we do to get rid of that variable y? How can we eliminate it? Well, we're not going to be able to add them. That's not going to get rid of it. So what we can do is subtract. And I personally like to rewrite whatever equation I'm going to be subtracting, and I write it right underneath. The reason why? I know that this negative has to distribute to each and every element of my equation. X becomes negative x, 2y became negative 2y. Negative 1 has to become positive 1. Now I can bring them together. 3x plus x gives me 2x. 2y and negative 2y cancel. It's exactly what we were looking for. Is equal to 5 plus 1 gives you 6. Divide both sides by 2. X equals 3. Now let's take one of our equations. You know me, I'm going to use the easiest one possible. Okay, I'm going to take x plus 2y. X plus 2y equals negative 1, or 3 plus 2y equals negative 1. Subtract 3 from both sides. 2y equals negative 4. Divide both sides by 2. Y equals negative 2. My ordered pair, x value of 3, y value of negative 2. 3 comma negative 2 is my solution to this system. Let's try one more example. And this example is nice for you because it is actually the first question on tonight's homework. And we look at it, y equals 3x plus 4 and y equals x minus 2. And most of you are saying, Mr. Finazzo, this is a silly way to solve this question. Why don't we just substitute in? We've got y equals and y equals. Still, some of you are saying, why don't I just grab a piece of graph paper and I can graph it? And all of you are right. There are multiple methods to solve any system. This is the method I want us to use today, the elimination method. So let's think about what we have to do. We notice y, and we know that they will get rid of each other quite easily. So let's subtract. Again, be careful when you subtract. Y minus y gives me 0 equals 3x minus x gives me 2x. And now here comes the really tricky part. 4 minus negative 2 will give me positive 2. So 4 plus 2 gives you 6. Personally, I like to rewrite the question so I can see exactly what I'm doing. Negative y equals negative x plus 2. Cross out the equation I just manipulated. Now I can see that kind of easily. Negative y, positive y, 0. They cancel. Negative x plus 3x, 2x. 2 plus 4 is 6. Let's solve. Negative 6 equals 2x. Negative 3 is equal to x. We've got a value for x. Let's go ahead. We'll take either equation or any of these 3 equations that we have up here, and we can solve. I'm going to actually use both to show you. First, y equals 3 times negative 3. plus 4, or y equals negative 9 plus 4, y is equal to negative 5. And now to check, I'll use this secondary equation. Negative 5 equals negative 3 minus 2. Is that true? Absolutely. And that's what we're going for. We've got our solution. X value of negative 3. Y value of negative 5. Elimination method. You're looking to line up variables. Look how everything's nice and neatly lined up. Y's and Y's, X's and X's. We like that. We can either add or subtract our equations. In doing that, we're going to eliminate one of our variables. Once we've eliminated one variable, we simply solve. Homework tonight. Finish the note page that you've just been working on. The first one has been done with you. I'd like you to finish the next 11, 12 total. Have a great rest of your night and weekend.